Hello everyone, welcome to Homework Help. If you find the video useful, please subscribe to the channel. In this video, we'll solve a quadratic word problem. The word problem is a playing field measures 140 meters by 50 meters. By increasing the rectangular area by the same amount on all sides, the new area will be exactly double the area of the existing field. By how much was each dimension increased? The first step is to draw a diagram for this problem because that will help us visualize what's given and what we need to find in this problem. As per the problem, the shape of the field is rectangle. Let's start by drawing a rectangle. The length of this rectangle is 140 meters. The width is 50 meters. As per the problem, the rectangular area is increased by the same amount on all sides. We can show that like this. Let's assume the increase in dimension on each side is x. Now we can draw another rectangle to show the new field. As per the first diagram, the length of the new field will be 140 plus 2x because the length is being extended by x on both sides. This is a very important concept we need to understand to solve this type of problem. Similarly, the width of the new field will be 50 plus 2x because the width is being increased by x meters on both sides. As per the problem, the new area will be exactly double the area of the existing field. Let's find the area of the existing field. The formula for area of rectangle is length times width. The length of the existing field is 140 meters. The width is 50 meters. The existing area is 7,000 meters square. Therefore, the area of the new field should be 7,000 times 2, which is equal to 14,000 meters square. In this problem, we have to find by how much was each dimension increased. As per the second rectangle we drew, each dimension was increased by 2x. This is another important concept we need to understand to solve this type of problem. So in order to find the increase in each dimension, we have to find the value of x. And for that, we have to write an equation with x. We have to use the formula for area of rectangle for the new playing field. The formula is length times width. As per the second diagram, the length is 140 plus 2x and the width is 50 plus 2x. This is the expression for area of the new field, and as per our prior analysis, this area should be equal to 14,000 meters square. So our equation will be This is the equation we have to solve to find the value of x. The first step is to distribute the terms in the parentheses using the FOIL method. 140 times 50 is 7,000. 140 times 2x is 280x. 2x times 50 is 100x. 2x times 2x is 4x squared. Next, we can combine like terms on the left side of the equation and rearrange the terms. We can start with the x squared term. 280x plus 100x is 380x. This is a quadratic equation. In order to solve this equation, we have to set it equal to 0. So we should subtract 14,000 from both sides. -7,000 minus 14,000 is equal to -7,000. We can reduce this equation by dividing each term by 4. Now we can solve this equation. We can use quadratic formula to solve this equation. In this equation, a is equal to 1, the coefficient of the x squared term, b is 95, and c is -1750. Now we can sub in the values. Now we can simplify this expression. 95 square is equal to 9025. -4 times 1 times -1750 is equal to +7,000. Next, we can add the terms under the square root. Square root of 16025 is equal to 126.6 rounded to 1 decimal place. We get two cases. The positive case is -95 plus 126.6 over 2. I get 31.6 over 2, which is equal to 15.8. This is the first solution of the equation. Now we can analyze the negative case. I get -221.6 over 2, which is equal to -110.8. In this problem, x represents the increase in the dimension on all sides of the playing field. Therefore, x cannot be a negative value. So the second answer, -110.8, is an invalid answer. So the valid value of x is 15.8 and the unit is meters. We have to find by how much was each dimension increased. As we discussed earlier, the increase is equal to 2x because the length of the existing field is 140 meters and the length of the new field will be 140 plus 2x. Similarly, the width also increases by 2x. Therefore, the increase in each dimension is equal to 2x. Now we can sub in the value of x as 15.8. I get 31.6 and the unit is meters. This should be the final answer for this problem. So each dimension was increased by 31.6 meters. So these are the steps you have to keep in mind to solve a problem like this one. I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.